Riemann sums are basically a way to estimate or approximate the area under a curve, really using your toolkit from much earlier in your math career, so more from like even geometry and algebra 1, right? So you're literally just using the length times width formula in order to approximate the area under the curve. You're going to have to know how to calculate it using left endpoints, right endpoints, and also midpoints. And you're going to have to understand whether that's an overestimation or an underestimation. So let's go ahead and take a look at a couple of my beautiful drawings to see an illustration of this. So here you'll see I basically have shown you what left-hand endpoints are going to look like. So these are left hand. How do we know that? Because you can see here all of these dots that I drew, these are on the left side, right? And you'll see down here, I have four numbers and I chose all the ones on the left, right? So from here, all I'm doing to calculate this area, which is highlighted in yellow there, is I'm literally just doing my length times width formula. So the width of all of these rectangles is just 1, right? All of these has a width of 1. Now I have to multiply that by the height. Well, in order to get that, I have to take this x value, or I'm sorry, for my first one, it would be this x value because I'm doing left, right? And I plug it into my function. And that's going to give me this output value or the height of that rectangle. So this one, for example, the height would be given by f of 0, this would be given by f of 1, and this would be given by f of 2. So now, quickly, before we move on to the other ones, let's go ahead and talk about whether it's an overestimation or an underestimation. So you can see here, when our function is increasing, right, or we have this positive slope here, you can see that this is an underestimation, right, because I'm missing out on all of this area. However, you'll see over here when our function is decreasing, this is actually an overestimation because I'm actually adding on that additional area. So it's just something to keep in mind. You do need to know whether it's an underestimation or an overestimation just to know how accurate your approximation is. Okay, so let's go ahead and now take a look at the same graph just with using right endpoints. So now again, we're going to have these four numbers down here on my number line, right? I forgot to draw a 0 there, but just know that it's there. So for here, I'm going to pick all of the ones on the right. So you can see here, this would be f of 1 to get my height, this would be f of 2 to get my height, and this would be f of 3 to get my height. I have the same widths of each rectangle, right? My widths of each one is going to be 1. And then I'm just going to multiply it by my output value, which represents my height. Again, I'm not going to go through this as much in depth, but just note here how it's different when you're doing right endpoints. Now when my function is increasing, it's an overestimation, and when it's decreasing, it's an underestimation. And finally, let's move on to our third type, which is using midpoints to calculate. In general, this is going to be the most accurate. So what you do here is you actually take the middle of all of your 4 points down here. And of course, I'm saying 4, but that's just how I have this split up. You could, of course, have more boxes. And actually, quick side note, the more boxes you have, the better approximation you're going to get. But anyway, so here I would take the middle of 0 and 1, which would just be 1/2. So this height here would be given by f of 1/2. I would take the middle of 1 and 2, which is 1.5 or 3 over 2. So this is f of 3 over 2 for that height. And then again, I would take it here, which would be 5 over 2 or 2.5, which would give me this height. So that would be f of 5 over 2. All right, let's go ahead and move on.